Also the wire you removed from the vehicle. Reconnect the electrical wire by soldering and use a heat shrink insulator. Apply a non-volatile anti-seize compound to the threads of the new sensor. Install the new sensor using an oxygen sensor socket and torque to the correct specification. Reconnect the wire and test drive the vehicle to ensure proper replacement.
You know, if you've got a vehicle that's running too rich, you might have some black smoke out of the tailpipe, and on this vehicle it's getting pretty poor mileage, Jim. When I went in and pulled the trouble codes out of the computer, I got a code 15. When I went to my trouble code chart, it simply says right here, code 15, open coolant sensor circuit. Now you've got a quick test of that coolant temp sensor, don't you?
Sure do. It's another one of the 2-minute tests that you can perform at home to find out if your coolant temperature sensor is working.
Okay.
Now here's one just like the one that's in this vehicle here. And, of course, it's out of the vehicle. It's not warm. It's cool. Inside of a coolant temperature sensor is a thermistor, which is a device that changes its resistance with temperature.
Sure.
Now, in this particular case, as I said, it's cool, so it's going to have a specific reading on the ohm meter. I'll take our meter and put it to about the 20,000 ohm scale, or the 20K scale,
okay,
and connect one lead to the body and the other one to the terminal, and we'll get a specific reading. In this case, about 1,930 or so ohms.
Sure.
Now remember, this is a cool one. This engine is quite warm. It's been running. So to illustrate the difference between a cool one and a warm one, we simply take and connect the black lead to a good ground, the positive lead to the sensor terminal, and here we can see we're at about 460 or 470 ohms. Quite a difference.
Yeah, it certainly is. Now, when you actually perform this test on your vehicle, you're going to be running the engine. You connect your meter up. You're going to run the engine for 2 minutes, and you're going to look for a 200 ohm difference within that 2-minute period. For sake of illustration, we did it this way. Now, if you don't find any change, boom, that's your problem. Replace the coolant temp sensor, and you're on the road again. If you do find a change, your coolant temp sensor is okay, and then you've got to get back in the book and do a little bit of work and go to your actual trouble code chart and follow your diagnostic chart out to find the problem. In this case, you'd probably find an open coolant sensor circuit wire or something in the ECM.
To test a coolant temperature sensor on the vehicle, disconnect the wire from the sensor and attach the red lead from a digital volt-ohm meter to the sensor terminal. Attach the black lead to a good engine ground near the sensor. Set the meter to the 20K scale. Observe and record the reading with the engine at ambient temperature. Start and run the engine for 2 minutes. Observe and compare the new reading to the first one taken. The minimum difference for a good sensor is 200 ohms. If the difference is less than 200 ohms, replace the sensor.
To replace your engine coolant temperature sensor, the tools you will need include a standard or metric wrench set, a hex wrench set, a regular blade screwdriver, liquid pipe thread sealant, a gallon of antifreeze, a large drain pan, and the correct coolant temperature sensor for your vehicle. Whenever working on your vehicle, always start repairs after the engine has cooled down. This will prevent personal injury due to hot engine coolant. The first step whenever working on the electrical system is to turn off all the accessories, including the ignition key. Then, disconnect the negative battery cable. This will keep spike voltages from damaging other components and will prevent the electric cooling fan from engaging during repairs. Before disconnecting the negative battery cable, be sure to write down any pre-programmed electronic radio stations on a piece of paper. This will allow quicker reprogramming when repairs are completed. On most vehicles, the engine coolant temperature sensor will be located either in the coolant passages of the intake manifold or near the thermostat housing. Next, open the radiator drain and lower the level of the fluid in the system. This will prevent coolant from spilling out onto the engine after the sensor has been removed. Make sure you have a drain pan to catch the old coolant. Then remove the radiator cap. On many late model vehicles, a bleeder plug must also be removed from the thermostat housing. Release the locking tab on the electrical connector and remove the electrical connector from the engine coolant temp sensor. Using a wrench or the appropriate socket, remove the old sensor. Compare the old sensor to the new one to be sure of correct replacement. Inspect the old coolant temperature sensor tip for scaling and deposits. If scaling is evident, we strongly recommend the cooling system be flushed and the engine coolant also be replaced to prevent scaling and deposits from forming on the new sensor. If the new temperature coolant sensor's threads are coated with a pipe sealant to prevent coolant leakage, no additional sealer is necessary. Install the new sensor and tighten it securely. Before reconnecting the electrical connector, inspect the connector for signs of damage and for wetness. If the connector is wet from engine coolant, inspect the entire wire for corrosion and replace as necessary. Reconnect the electrical connector to the new sensor, making sure the locking tab is secure. Add a new coolant mixture of 50% water, 50% antifreeze to the radiator until it reaches the radiator cap seat. We recommend you do not reuse the old engine coolant that was removed. On vehicles where a threaded bleeder plug was removed, add coolant into the radiator until it reaches the bottom of the bleeder plug hole. With sealer on the threads, reinstall the bleeder plug in the hole and tighten it securely. After installing the bleeder plug, continue to fill the radiator until it reaches the radiator cap seat. Reinstall the radiator cap. On vehicles with a coolant reservoir, fill with new engine coolant until the level is between the minimum and maximum marks. Reconnect the negative battery cable. Start the engine and run until normal operating temperature is reached. With the engine idling, add coolant to the reservoir as needed. And lastly, reprogram the electronic radio stations if so equipped.
To replace your coolant temperature sensor, follow these steps. Turn off all accessories and make sure the ignition key is in the off position. Locate the coolant temperature sensor, which can be found in the engine block. Drain the engine coolant from the radiator. Disconnect the coolant temperature sensor electrical lead. Remove the sensor from the engine. Once removed, inspect the tip of the sensor for scaling or rust deposits. If any are found, flush and refill the cooling system. Compare the new and old sensor to ensure a proper fit. Coat the threads of the new sensor with a liquid pipe sealer and install it in the engine block, being sure to start it in the threads by hand. Tighten the sensor securely. Reconnect the electrical connection at the sensor. Refill the cooling system with a new mixture of antifreeze and water.
The idle air control motor, or IAC motor as we'll call it, is a computer-operated valve that controls bypass air around the throttle plate to increase or decrease the idle speed for different conditions. Symptoms of an idle air control problem include erratic or noticeably high or low idle speeds. The items you will need to test and service an IAC motor include a small flat blade screwdriver, a digital volt-ohm meter, a standard or metric wrench set, some spray carburetor cleaner, and a clean shop towel. Make sure the vehicle is in park or neutral and the parking brake is set. The first step in testing your IAC motor is to check the basic operation with the engine cold. Start the engine and verify that the engine runs at high idle. This may only last a few seconds or may last up to 45 seconds. Allow the engine to continue running.